I need help with these math workshop problems. Table 3, you can add a point. I need table 4, you can add a point. I need help with these math workshop problems. I would love to hear from a table that, okay, table 4. Can you help me with the first one?
I got 4n minus 5n minus 3.
Minus.
That's 5n.
He got it back.
Minus 3.
Okay, you may add a point for you because you did volunteer, which was nice. I would love to have, thank you, table 6. Can you help? Yes, please.
I got negative 3 plus 4n minus 4n.
Negative, you got, tell me again, negative 3
Plus 4n.
plus 4n
Minus 4n.
minus 4m. Okay, and then you may add a point. Table 3, can you get involved? Which one of these do you think is correct?
It's the last one.
Okay, the blue one is correct-ish. Is it as good as it could be?
It should be negative 4m plus 4n minus 3.
You may add a point for your group. Now, why do we actually care? Yes, dear. You don't have a number strip, even though I put one on every single group set?
That should be subtracting a point.
Deduction?
Oh my goodness. Promise we'll forgive you today.
You think maybe you ought to add one more just
Yeah, nah. I'm pretty sure you're already at 2, right? I thought so. 2 is good for now. We're only a minute 50 into the recording. That's a point a minute. My God, chill out. He was, I don't know, 2m minus 6m. I agree it should be the negative 4m. But the bottom is better because we actually put it in ABC order, m, n, and then the piece with no variable. Yes, Hunter?
The bottom one, is that just your preference?
That is my preference. Would you be counted off for the middle? No. Would you be counted off for the top? Well, yeah, because it shouldn't be a 5. No, it's just my preference. I'm like you. I like to go ahead and do things the way I think the ACT we're doing or the way my next math teacher's going to do them. So I always put things in order. Do you have to? No. Hunter is correct. Hunter, good question. You can add a point. Okay. Whoa. Yeah, but your table normally writes up 1 point.
But we haven't got one yet.
You haven't even gotten 1 point? We're going to let table 2 answer because they need at least 1 point. My God.
Okay.
Please help.
I got negative 5g squared plus 3g.
Okay, I'm pretty sure he's right, but again, I am not so good when it comes to the negative, so I would have had to, I did. You may have a point for that. I have to distribute the negative and have an extra step like I'm going to do here in blue. It just helped me. That way when I combine my terms, for sure it is negative 5g squared, as he pointed out, and it is a positive 3g. Do you have to do that? No, but if you're consistently making mistakes with the negatives, then I highly recommend it. Highly, highly, highly. Yes, table 1. Do what? The next one? You want to go ahead and do the next one today? You're going to remind me tomorrow. We're going to remind you tomorrow, and you're going to get the first point tomorrow. We're lazy today. Okay, get out your ACT stuff from yesterday. We had just gotten done with the one with the Venn diagram, and we were starting the one with absolute value, and we ran out of time. I'm going to go ahead and get that absolute value question on the screen. Some people were already signed. We were on 5. We haven't, not everyone's answered 5. You're not going to get 5 right if you're either not doing math in your head or writing some math down. Surely you're doing one or the other. Just guessing is probably not going to work on this one, although we'll talk about my strategy in just a second. I gave you a minute yesterday, but for kicks and giggles, I'll give you 30 more seconds today. So you may go. Bless you.
slide that up just a little bit.
You want miracles from me? It's not annoying at all. I think we discussed it yesterday, but let's be honest, you weren't really listening because it was like a minute before the bell, so it's not going to hurt to go over it again. Okay, I would love to hear what table 5 thinks the answer is.
I don't think it's
It doesn't matter.
right. I think yes,
C. Okay, table 1, y'all got an answer? A, I got C, A. Table 2? E. E. Oh, now you know once they pick a letter and everyone's on board now it's E. Okay, let's actually find out. If I was guessing, I'm not sure I would guess my way into the right answer because again, when I start getting desperate, I start having this Goldilocks kind of logic, and then I knock off the too big, and I knock off the too small, and I pick one in the middle and pretend it's just right. And yes, it normally works, but on this one it's not going to work, because as you heard, most people think the answer is E, and that's the smallest thing up there. So, sadly, you're not going to guess your way into an absolute value problem. However, the math is pretty simple. 2 minus 9, well, that's negative 7. But the absolute value bars make everything positive, so it's really 2 times 7, which is 14. The other part, I know you can do 4 plus 2 is 6. 3 times 6 is 18. So you end up having 14 minus 18, and that is negative 4. If you got negative 14 minus 18, if you got negative 32, which was answer choice A, then you did not understand those absolute value bars make everything positive, because you thought it was going to be negative 14 minus 18, which is negative 32. You're forgetting about those bars. They make everything positive. Okay, are there any questions on number 5? We'll do number 6, and then we'll call it a day on ACT prep. I'm going to warn you, number 6 is a little hard to read because there is a graph involved. But I feel like it's a good one because of what we just talked about yesterday. Let me see if I can get that off the screen. Okay, you can have the full minute because, my gosh, it's hard to read that from far away. Yes, sir. Okay, does anyone need a little longer? Perfect. Okay. Okay. Which answer choice did I eliminate?
J.
I did get rid of, I got rid of 2 different ones. But the first one, not even looking at the math, I decided K was probably not it. I normally, unless I like really think it's that, maybe in English it's that, very rarely is math and is it cannot be determined from the information. Okay, and then she says it can't be J because 4, 1 would be right here, and they really don't look like they intersect right here. Now, here's the good thing about the test is that it's yours to write on. So hopefully, you'll just quickly with your pencil try to make the 2 lines hit. And when I do that, you're like, hey, I think that's, I don't know, Miss Compton can't really draw a straight line. So you're like, somewhere in here-ish. Okay. So I agree with her. K's out, J's out. What's the answer? It is G. It is G. I know I didn't do a very good job. My lines are a little skewed, but it should have crossed here. Maybe if I redrew my line. Now that I know where they're supposed to cross, maybe I can actually make it cross there. Maybe I can force that. -1, 5 doesn't really seem like a good spot either. So I would have eliminated F as well. So I was either guessing G or H to begin with. And then I gave out my own secret, so I'm not even going to ask you because I gave it out right then. I hate it when I do that. J helped me realize the answer was G. Because J and G are...
the inverses.
Okay, I'm going to give 2 and 3 a point for that. I liked inverses, and then I heard reciprocals over here as well. So, and for those of us who don't speak math lingo, they're flip-flopped. So they look so similar. I knew that, like, I guess they get really lazy, or they're trying to tell me, hey, the answer for real is G. Like, it's as easy as it looks. Now, it's interesting that they gave us an equation, 2 different equations as well. Now, could we have plugged in 1, 4, and actually a 1 plus 4 is 5?
Yeah.
And then -2 times 1 plus 4, that really is 2. We could have checked it out, but again, Taylor's trying to do this as quickly as possible. He wants to spend as little time as possible on those first 30 questions. He was given the graph. My golly, he can draw his line up, figure out, make a good guess of where they connect, and not actually have to plug it into the equations. So I don't feel like the equations were necessary. Okay, are there any questions on that one? Yes, ma'am.
Another question for that.
Yes. Okay, so go ahead and put that away, and you already have out your foldy thing, so let's get to the foldy thing. The first day of class, when I gave you a syllabus, I gave you a course outline for you to take home and get your mommy to sign or whoever. And on that course outline, it listed what different units we were going to cover. We're in the first unit on number theory. Obviously, we talked about the difference between a discrete function and continuous function. Today, we're actually going to talk about how to classify numbers. You probably discussed this in your Algebra 2 or Trig class, but it can't hurt to practice again. It really can't. Tomorrow is going to be a fun day with scissors and cutting and your group. Yay! It's going to be a fun day. Tomorrow. So you've got to make sure you understand today, not only for your own sanity and your own worksheet, but you just can't let your group down tomorrow because I think there are 40 boxes and you have to do 2, so that'd be 80 boxes you need to cut out and get in the right groups. So you're going to need everyone to know what on God's green earth they're doing. Okay. So we are going to talk only about real numbers in here. Does anyone know what a not real number is called? Say it again. At table 6, you can get another point. They're called imaginary. So, you know, you either have real friends or you had, when you were younger, you had imaginary friends. We don't have real numbers and fake numbers. We don't call them fake. We call them imaginary. And they're not fake. They exist. They're just a pain in the rear, and we won't get to them. Yeah. You know, they exist. You saw them. They existed. Okay. So we're going to go to the first flap that says irrational, and we're going to write some stuff behind it to help us with it. And actually, instead of irrational, let's start down at the very bottom. Let's start with the easy one at natural. Okay. A long time ago. A long time ago. You people had to come up with numbers. Why did they have to come up with numbers? What kind of stuff they want to count?
Food.
They might want to count food. Why did people come up with numbers? They needed to do something. What were they going to do with the numbers?
Math.
They would use them to keep track of things. I'm thinking of a word. Say it again. Travel. They might for traveling. I'm thinking of a word. Yeah, table so you can have the point. I'm thinking of trading. They had to come up with numbers for trading purposes. Okay, so me and Hunter. He can have. Hunter, you look like you might have some cows, maybe, and I'm gonna have pigs. So he's gonna give me 2 cows, and I'm gonna give him 5 pigs. So that's what they came up with them for, and that's what they call them, counting numbers. And if you want to make a note to yourself, I always think of pigs or cows or some sort of animal that we would have traded. If you would have traded it, like you can trade 7 cows. You can't trade 7.2 cows. You can trade 15 cows. You can't trade 15 3/4. We're talking about fully alive ones too. We're not doing some partial surgery and I'm giving you half the cow. No, I mean fully alive animals. If you need to add alive because you're trying to kill things and slice them in weird sections, that's weird. We're not doing that. I mean fully alive animals we're going to trade. Okay, so when we think of these numbers, they're natural numbers. What's the lowest counting number we would probably use? 1. And then here comes the 1, 2, 3, 4, and then of course you know that keeps on going forever. He might have 37 cows, and I might have 52 pigs. I don't know. And then I heard someone ask a good question. What number's left off this list that you really want to add to it? Who said it? You can add your point. Why do we want to add 0? I mean, it's a low number like this. Normally when we do 1, 2, 3, 4, 5, you might want to include 0. Why is 0 not included with these counting numbers? You can't count nothing if you have nothing. Or if we're going back to the terms of trading, if he has 0 cows, there's no way I'm giving him my 5 pigs. There's no way. He's got to have some number of cows in order for us to actually have a trade. He's just going to starve. Okay, so the next thing up is called whole numbers. And the only thing different is that we're going to include 0. So whole numbers are just like the counting numbers, but we're willing to take 0 into consideration. Now I know I gave you my quick history lesson on the trading. There's a reason why 0 popped up as well. I swear numbers are interesting, and how they got, someone had to find them. So how they got found out is really cool. If you're interested in that, it's really explained well in a kid book called The Number Devil. And I'd let you borrow it if you wanted. It's really cute. Yeah, I know. I already heard that. I'm not reading a book about math. Are you serious? Okay. Then, so we have 0 through 4, and then life happens, and we got super fancy, and we did integers. Anyone know what's going to be different with integers? We're going to include, you said it really loud, I'm going to give it to you too. Integers are going to include the negatives, so I'm going to put some dots before. It's going to include -3, -2, -1, 0, 1, 2, 3, and so forth. And then for those of us who can handle the deep thoughts for the day, you can count to 1 to 1,000,000 with this number. But you could count negative infinity to positive infinity with this number. You think this list is really about double this list because of all the negatives. I mean, every positive number has a negative reciprocal, or whatever you want to call it. A negative friend, counterpart. I don't know. Deep thoughts. So if you need words, because some of us would like English, integers include whole numbers and their opposites. That's one way to say negatives. They're opposites. And I could definitely zoom in on that so you could see what it says. Okay, so we lived in a world that just had counting numbers. We added 0, we added in the negatives, then what do you think we added in after that? Okay, I see it says rational, but what kind of numbers? Decimals and fractions. So we're going to, if you want to make a little note to yourself, this is going to be in the decimals and fractions. And we're actually going to be very specific about what kind of decimals and fractions. It's what I'm going to write in the blank above. So a rational number, it's a number that can be written as A over B, and then there's one rule I need to add. Well, I'm going to say where A and B are integers, and there's one more thing I need to add. There's a rule.
Where it can be divided?
Okay, so a rational number is a number that can be written as a fraction, because any decimal, we could probably turn it into some sort of a fraction. You know, 1/2, 0.5, they mean the same thing. 0.25, 1/4, they mean the same thing. But there's a rule about what can go in B. What number cannot be included in that denominator. B cannot be equal to what? It's 0. So we have a cardinal rule in math class. I used to have my 10 Commandments math. I really don't know what happened to them this summer. I'm really curious to find them. Maybe they'll pop up when we move. There's a cardinal math rule that you can't have a 0 in the denominator. In fact, in that number theory, or this number devil book, good grief. In the number devil book, they talk about how you allow division by 0. You actually end up saying that 0, the number is equal to 1, and then it just kind of makes all of math fall apart. So basically, if you're not wanting life to implode like a nuclear thing, you can never put 0 in the bottom, ever. You're like, Miss Compton, I'm not trying to get that deep today. Totally with you. Totally with you. Okay, so we have rational numbers, which are pretty numbers, like 1/4, 0.25, 1/2, 0.5. Pretty numbers. And then we get to this world of irrational numbers. And irrational sound like they're the opposite of rational, because they are. It's a number that cannot be written as A over B, where A and B are integers. And you're like, that sounds nice. So, yes, dear. Yes, dear. That sounds nice, but how do I know when I found one? Because that font doesn't help me. So the important thing to remember with an irrational number is that the decimal form, it neither terminates nor repeats. Okay, so if you have a repeating decimal like 1.333333 and you're like, yeah, Miss Compton, got it, the next number's 3. That would be a rational number. But if there is no pattern, or it never terminates, it is irrational. What does terminate mean in math?
Like in
Okay, I'll give 2 and 3. Yeah, 2 and 3 can both have a point. And they're both going to have an end. So like 1.25, that has a clear end. Okay, are there any questions about our little slips? Okay, now we have this cute little chart, because we're so cute. And it says that we're in the real number system, because again, we're not talking about your imaginary friends today. So there are irrational, rational, integers, whole numbers, natural numbers, and everything we talked about, integers, whole numbers, and natural numbers, they're all subsets of rational. In fact, natural numbers, as we discussed, led to whole numbers led to integers led to rational, and then irrational is in a league of its own. So I'm going to give an example, and I need to know where to put it on this chart. So, for instance, where do I put the number 5? I heard it. Okay, I heard it from multiple groups, so every group can have a point. Well, then let's step it up a notch. Where can I point? Good grief. 0.875. Okay, the first loudest one I heard was 2, but I know I saw mouths moving at all the groups, so every group can have one. Okay, how many points do you have, one? How many points do you have? 5. Okay, I knew table 5 needed me. Okay, so I'm going to let table 5 answer this one first. If they can't, then you can. Where do I put 0? Okay. You may have your point. Okay, let's let table... How many do y'all have? 4. Okay, let's let you have this one. Where do I put -99? That is correct. You may have your point. Okay, let's see. Table 1, I'll give you a turn. Where do I put 84? That is correct. You may have your point. You were making me concerned there. Table 5 was ready to steal.
I don't want to be the only one to answer.
Yeah, no, you can be the only one. You can be fancy. You can be fancy. And then tomorrow, and during the group activity, you better hope they figured it out by then. Oh, Lord. Okay, I let you go. Let's see. Table 3, how many points do y'all have?
You have 7.
I thought so. Table 2? Table 6? How many points do y'all have? That's what I thought. Okay, back to table 5. Table 5, where did I put -18? Thank you. Table 4, where do I put pi? Yes. It doesn't have a set end. Okay, and then let's see. Where do I put table 5? I'll let you do it again. Where do I put 0.2 repeating? Okay, you can have your point. And then I'm going to list a couple more examples in rational. 1/3, maybe 0.5, 3/4. And then there's another irrational one I want to do. I'm looking for some irrational numbers. Does anyone know any other irrational numbers?
Rational?
Irrational. Who said that? Did you say that? Did I just see it come out your mouth? That was you, right? You can have your point.
The E thing.
The E thing. So you talked about E when you were talking about exponential functions and logarithmic functions. It stood for 2.17, and then it had a whole lot of, and it kept on going forever. I'll give you a hint. E and pi both have buttons on your calculator because they're irrational and we don't know the set pattern. So if there was a special calculator button for it, it was probably irrational. And then another example of an irrational is the square root of any number that's not a perfect square. So is square root of 2 irrational?
Yeah.
Yes, it actually ends up being 1.4, 142,135, and like it never has a set thing. Okay, so any irrational as long as the square root of not a perfect square. So is the square root of 8 an irrational number? Is the square root of 9 an irrational number? No, it's a perfect square. Duh, you knew that. So how am I going to trick you on this worksheet in a second? I'm going to put stuff like the square root of 9, and you're going to automatically say, oh, irrational. And you're like, duh, square root of 9, what is the square root of 9?
3.
So where should I have actually put the square root of 9?
Natural.
Natural, because it actually is a natural thing that occurs.
All 3 of them.
Do what, dear?
Doesn't it go in integers, whole numbers too?
Yes, so if it is a natural number, like 5, it is also a whole number, it is also an integer, it is also a rational number. A 0 is a whole number, an integer, and a rational number. An integer is also a rational number. It gets to be all the things except irrational. It is all the things. I always go with the smallest though, so you don't have to list it all out. You don't have to say 5 is natural, whole, integer, rational. My God, that's a lot of stuff to list. I think your teacher made you do that in algebra to a trig. Here in discrete, all you gotta do is tell me the smallest. So 5 is natural. Just natural. I get it to all the stuff after that. I got it. Woohoo. Okay, are there any questions about this? Okay, well, as long as you can keep your act together, we're going to boost everyone up to the 5 if you're not already at the 5 in just a minute. Yes, Taylor? You can go fill out your water. Yes? Yes, dear.